Hi, I'm David Green. I'm a ruminant field technical specialist with Diamond V. Work primarily in the southeast, but work nationwide and do some international work as well. Today I want to share with you some things around the feeding operation efficiency and maximizing some key things around your feeding center so you can actually be more profitable for your operation. So the title of my talk is Key Factors in Maximizing Your Feeding Operation. And if we get started in this, we look at the background. Feed is the largest daily expense for dairy farmers today. There's a lot of cost around just the feed expense, but there's also many other costs around the feeding operation, so the activities around the feeding operation. So we need to be able to monitor that and manage that, and then look at the efficiency side of it and see how we can best help the producers to maximize their profitability. So here's just an example. If we look on for a 500 cow dairy that has a $6.50 per day feed cost, that's $1 million annually just for their feed cost alone. If we could cut 3% shrink, that's another $35,000 in savings that we could do annually. If we could gain 2% feed efficiency, that's $23,000. But if we look at what the cost savings could be just to save $2.50 a ton on every ton of as-fed TMR they deliver, if the herd is feeding 110 pounds as-fed, that's another $25,000 annually. So if we can save those opportunities, gain efficiency, what does that do for milk production and cow health? It's a big opportunity for a dairy to increase their profitability. So if we look, there's different areas of efficiency that we need to be focusing on, and around that is properly designing the facility. We need to properly size our equipment. If we buy equipment that's too big, as often as I see in the industry today, then we're not actually maximizing our investment. So we need to be sure that we have our properly sized equipment, but the feeding process cannot be interfered with. Cows are creatures of habit. They want to be fed, they want to eat the same thing every day. So anything that we can do to minimize any inconsistencies there, we need to do. So if we look at the ration, we need to stop sorting. That's still one of the biggest things that I see in the industry. It's really hard for producers to stop sorting in cows. So as your nutritionist, as you work with your nutritionist, you need to understand how we can do that and be sure that we get it done. Also, I've got some data around push-up frequency. If we're feeding cows and we're trying to measure refusals, if we don't push the feed up to where the cows can eat it, then we've got an opportunity for refusals that probably wouldn't have been refusals if we'd had pushed it up. So I've got some data around that to look at. Another big one is maintain equipment. There's an opportunity there that if we don't maintain our equipment, we don't keep it in good working condition, then it's not going to provide the most consistent ration for our cows. We got to understand our equipment. Every mixer or mixer company, they make a mixer that mixes feed and can do it well, but they all don't do it the same. So we have to understand the mixers that we have and understand how we make them mix well. We got to manage shrink. Today, a lot of dairies have got a line item just for shrink, and that's about the number 4 or number 5 cost or expense on dairies today. So we have to put a monitoring system in place to actually manage that. Contingency plans are a huge deal. If we have breakdowns, which we all have on dairies every day, so we have to be sure that we have a contingency plan, and everybody in that feeding program needs to understand what it is and how to react on it when something happens. But probably most important is we need a monitoring system, basically to understand where are we at, what do we need to manage, and what area of focus do we need to work on. So let's go into feed center design a little bit. If we look, we always want to be sure that off-farm traffic is separate from farm mixing traffic. We need to have a platform scale system in place. If we don't have a platform scale system, it's kind of hard to measure your shrink. We need to adequately size our bays. We don't need too big a bays, have too much investment into something that we don't need, but we definitely don't need them too small either. as we design these, we want to try to put flex bays. And what I mean by flex bays is basically that we need extra bays just in case there's an opportunity for a good buy on an ingredient or something like that. So we've got an opportunity, or we've got a place to store some of those ingredients. We need to be able to unload from various truck types. Certain times of the year or truck availability, there may be an opportunity to get a freight rate that would be less on a different type of truck. And we need to be able to manage that any time that we can. So as I started designing feed centers, I started looking at the traffic patterns and the flow patterns on the farm around the feeding area. So I came up with what I've called the feed zone model. It's just zones 1 through 5. It's important for a couple of major reasons. Safety is the big thing. We don't want to get anything traffic crossing up where we could have opportunity for injury or accidents. Efficiency. If you look at this, everything kind of flows downhill. We go from one side to the other. We keep things going in a proper manner. Biosecurity. As time goes on, biosecurity is going to get more important on these farms, and we need to understand that we could be ahead of the game. If we're designing a new facility that's going to be there for many years, then we need to be sure we understand that we have to manage biosecurity. But it's the overall organization and culture of the farm and the flow of the farm, and it makes everything much more manageable and easier to keep an eye on what needs to be happening at that time. So if we look, zone 1, this is basically the loading zone. This is the area where all TMRs are made. We cannot have any other vehicles or any other traffic in this area except for the loader and a mixer. This area should not be interfered with at any time during the loading phase. Zones 1 and Zone 3 are very critical areas to keeping cows fed. Zone 1 is where we make loads, but Zone 3 is the traffic pattern of the mixer that goes out, and we'll discuss it in just a moment. Zone 2, this is the off-farm ingredient loading zone. All off-farm deliveries are in this area of the feed center. I'll show you a picture in a moment that'll describe it a little more in depth. We should have minimal loader traffic in this area to prevent any kind of accidents with delivery trucks or off-farm traffic. Zone 3, that's, as I mentioned before, that's the traffic flow outside the feed center for the feeding equipment. This area needs to be smooth. If we have rough travel areas for the mixer wagons, then that's the opportunity for errors on the load cells of the mixers. Zone 4, that's the traffic flow outside the feed center for all off-farm deliveries. The traffic pattern for this shouldn't ever cross the on-farm delivery traffic. Now, I know as we're remodeling facilities and we've got older facilities that we're adding on, this is sometimes hard to do, but we still need to be mindful, and it may be that you have delivery times that are set when are not, you're not mixing or delivering traffic to the cows. Zone 5 is the traffic flow area for staging forages or going to get forages with your mixer wagon if you're not staging them at the feed center. This can be outside or inside the feed center depending on the type that we have. This may be an area of constant movement, or it could be timed. If you're using the same employees to make loads of feed as you do stage loads of feed, then it can be alternated as to when we do it. So here's just an example. We look at a feed center. You can look right here at Zone 1. This area down here is all basically, all that does is it basically covers any areas, any time that you're making a load of feed. Zone 1 doesn't need to have any other traffic except your loader and your mixer wagon. Zone 2, that's up on this side of the layout that you're seeing here. That's where your off-farm deliveries take place. This can take place when you're not making a pre-batch or pre-mix and need a loader in that area. Zone 3 is down on the opposite side here of the feed center where the feed traffic, that's the mixer wagons that are going to the barn, actually travel in that area. You don't want that to cross Zone 4. Zone 4 is where you need your traffic, your off-farm traffic coming from the road, across platform scales, and straight to the feed center. It should never cross your pattern of feeding those cattle. And Zone 5 That's the area right here where we're staging forages. If you notice in this feed center, we're staging the forages from the outside and loading out from the inside. So this allows us to be in the forage area to deliver forage to the feed center, but we're not interfering with mixing of feed. Here's an example. This was you may be going to Stott's Farm for your lab for the class. So this is the old Stott's Farm, and if you notice right here, zone 1, 2, 3, 4, and 5 are all on Main Street. So this is an opportunity for us that we're going to run into issues either with delivery, with mixing, with making loads or delivering loads. This is a huge problem for us. So everything happens on what I would call Main Street right here. If we look at the new facility, this design allows us to stay separate. So if you got zone 1, that's inside the feed center. You know, the type feed center that we have here is an outside unload, inside feed out. So zone 2 is going to be right here on the outside because we're delivering inside the feed center from outside. Zone 3, the delivery traffic is coming out of the building and going to the farm, or to the barns where the cows are. And then zone 4, this is where every ingredient comes across scales and comes to the feed center. So you notice the feed center traffic, the off-farm deliveries are right here, but the farm traffic delivering feed goes this way. And then zone 5, we bring it in the same way we do zone 4. So both of those are coming off the farm and into the feed center, so they're in the same traffic pattern. So when we're looking at a feed center, we need to understand, you know, every farm is different, so what type of management system do we need for that farm? And as I'm looking at redesigning these or building new ones, I have to really keep this in mind, because I don't want a totally automated system for somebody that doesn't have a good mechanic or doesn't have a lot of mechanical skills. Excuse me. Minimal mechanization is what I would call concrete and a loader and a mixer. That's very common. You know, most people don't like a lot of moving parts to give trouble. A combination feed center would be a feed center that has maybe upright bins and a lot of flat storage as well. You know, it can be a new greenfield site or it can be remodeled. We do a lot of work with all of them. But again, you got to understand what meets the farm. Every farm is different. We have to understand what their management style needs and what fits their operation. So here's one, a totally automated facility that I did. And if you look, all the ingredients are loaded in the bays from the outside and then carried by conveyor up into a weigh box. Well, then the weigh box is a staging area for the next load that's going to go to the mixer wagon. So that's an opportunity. We can actually stage loads while we're still delivering loads. So that's an efficiency gain that we get, but this is totally automated. There's a lot of grease fittings, a lot of maintenance on this, and if we don't have a good maintenance program on our farm, this is not the type system that we need. If we have somebody that really likes that, enjoys that, and wants to be able to mix feed easy, that's an opportunity for a facility like this. Here's a totally automated robot facility. So if you look, we just keep these bins full of different ingredients, and the robot will actually go around and then it's computerized to load the amount of ingredients that goes in it. And then as it loads, it mixes and it goes through the barn, and if you notice, it's pushing up feed at the same time that it's delivering feed. So that's a good option that we would like to have. But then you've got a facility, here we got 2 stationary mixers. You know, when we designed this one, we wanted as little mechanization as we can. So we've actually got the 2 stationary mixers. We didn't want to have conveyors to unload out of it. This is an outside unload, inside feed out type facility. Ingredients come through the bays and then are loaded out right here. So it's a first in, first out. And as you notice, we're mixing in those stationary mixers, and then it drops gravity flow down into the mixer trucks and then delivered around to the cows or into the barn if it's a pre-mix. And if you look at this facility, these are different types that you can do. All the TMR loads are made in the center area of this barn, and then all ingredients will come in and be unloaded on the outsides of the barn so we don't interfere with making TMR loads of feed. This facility is similar to what I showed with the zone. You got outside unload, inside feed out on the forage side, but then your other ingredients are all down here, and deliveries can come in but never interfere with making TMR loads right here in Zone 1. So here's a remodeled feed center. This was just a really short feed center that had backs in these walls. This dairy actually milks 5 dairies, 6,200 cows at this facility, but they're 90 miles apart. So we looked at the efficiency side of it. We can make all premixes at this facility, and we actually saving money. So on the inside, this big barn was actually a hay storage facility. So we took the backs of these walls out, made this outside unload, inside feed out type facility, which makes this very, very efficient. This is where we store any mineral mixes that are bought off the farm, but that are loaded out down on this end. You can also go with bins. Bins can be a really good option. The big thing to remember with a bin type setup is we need to be, minutes are critical. So if we've got a small auger in these bins, then it takes a long time to load a feed. These bins, if you notice, they have a 12-inch auger. We can load into a mixer about 4,500 pounds a minute. Here's just an example of a feed center. This is what we started with. This was a customer I did, and if you look, this is pretty typical of what we see on a lot of dairies today. But here's where we're at now. We designed one. It's a very simple system. Got bays on one side. We stage forages on this side. And here's your loadout and your back-end loadout area for your mixer. And if we look at the numbers on this, a lot of people really think, well, I can't afford something like this. But there is an opportunity if we truly look at the numbers. This herd was 1,260 cows. The new feed center was just over $500,000. We reduced feeding time by 4.5 hours. If you look, the hours, $94.30. That's $154,000 annually that we saved just by reduced feeding time. We also cut his shrink by 6.2%. That's $174,000. So a total payback of 1.52 years on this feed center. So I don't know anybody that would not want to take an investment like that. After a year and a half, then this investment's just going to make him money. So managing shrink. If we go into this, I mentioned earlier, shrink is the number 4 or 5 expense on the farm today. And most people don't even know don't manage it, don't know how to monitor it. So that's where we can come in and try to help do that. And you, going back to the farm or going into the industry, you need to understand so you can help producers as well. So shrink occurs all the way from the field to the feed bunk. We have to understand how we can manage that every step of the way. Everyone involved in the feeding operation has to understand what it takes to minimize the shrink loss that we have. So here's, as I mentioned when I started my talk, I've got several herds that I've been pulling shrink data from. So if you look, here's different forages and different ingredients that we pull, that we look at. So we've got corn silage in a pile or pit, ranging from 4.8 to 15%, with an average of 10.2%. Corn silage in a bag, you can see 6.5 to 14. But one of the big keys that you got to look at that really bothers me is bag ingredients, 2% to 19% variation. That's 12.5% average on that, on typically the most expensive ingredient that's going into the ration. So why is that? If a ration calls for 40 or 45 pounds, typically 50 pounds goes into that ration. If those cows do not perform to that extra amount that you've put in there, then that's considered shrink. We've lost that. So if we look at shrink based off of the type of feed center or storage facility that we have, shrink in a conventional feed center, which would be a 3-sided open front feed center. It ranges from 2.5 to 11% with a 4.8% average. Enclosed feed center, 2 to 7% with a 3.8 average. And then upright and overhead bins, where we would typically think would be less, is 3.9%. And that's because of wind. Most feed bins are loaded outside, and wind is a major problem and can cause a lot of shrink. But if we look, the average for these herds is 8.1%, and when I started back 2 years ago, we were at over 14% on these herds. So we have the opportunity to reduce this and actually allow these producers to get the value out of the money they've spent on their ingredients. When we make pre-mixes or pre-batches, and what I mean by that is we take all dry ingredients, mix it into a high-cal pre-batch or a low-cal pre-batch. If we do that, load it in a mixer and bring it around and unload it back into the feed center, every time we do that, that's about 1% shrink. Every time. So we need to understand, how can we potentially save that money? That's your most, your blend is your most expensive ingredient going into that final TMR. So how can we reduce that? That's where we've started using stationary mixers to make these pre-batches and then taking it by drag conveyor directly into a bay to load out, rather than loading it up and bringing it around in a feed mixer. You know, our realistic goal, I think we can do this. I've got some herds that are doing it, but I would like to see us in that 4.5% to 5% range on forages, grains, and all, on total shrink on the farm. You know, what's important to monitor on shrink? Let's just look at an example. You got that $6.50 a cow per day feed cost that I mentioned earlier. If it's 8% shrink, that's 52 cents a head a day, or $94,000 on a 500 cow dairy. If we can cut that in half, you know, we're not going to get it to zero, but if we can cut that in half down to 4%, that's 26 cents a head a day. Many producers argue with you over a nickel to 10 cents a day when we're giving away 26 to 50 cents on the farm. So it's an opportunity for us to help them manage what they're doing better. We need to have a monitoring system in place. It doesn't do us any good if we don't understand where we're at. You know, we got to have a starting point, and then we got to have a monitoring system in place to see if we actually have success or failure in the systems or protocols that we've put in place. You know, we need to measure the efficiency of the feeding program. We do that by looking at cameras. We put cameras up strategically placed on the farm. We got to get the cows fed, as the main goal, but is there opportunities that we can do that more efficiently? You know, we understand that all costs associated with making, mixing, and delivering feed is a huge expense, so we have to manage that as well as we can. So I've got some spreadsheets that I've had help developed, and if you look, labor, loading, and mixing and delivery are three areas. There are three key areas on this spreadsheet. But if you look at the total cost of loading, mixing, and delivering feed, with the 48 herds I put through this, we range from $3.15 to $10.21, with an average of $6.12. So you need to understand, where is your herd? Where is your client's herd that you're working with? That's something that we need to know, because that's a lot of money. You know, the cost of making, mixing, delivering of a 500 cow herd, if the ration is 110 pounds as fed, at $3.15, it's $31,000. If it's $10.21, it's $102,000. So where is your herd? Where are you at in between that? You know, hopefully you're better. If we manage to put some herds through the spreadsheet, hopefully they're better than $3.15, but that's the best I've seen so far. But I sure hope you're not in the $10 range. That's a lot of money. So let's think about this from an efficiency side. If you have a 180 horsepower tractor, 1,100 cubic foot mixer, the cost to operate that per hour is about $72.50. If you make 10 loads a day and you can cut 10 minutes a load off of every load you make, that's 1.67 hours a day. That's $44,000 a year. You know, most producers now, they'll take about 30 to 45 minutes to make, mix, and deliver a complete turn time on a load of feed. Our goal is to try to get that in 20 to 25 minutes or less. So if we can save that 10 minutes a load, every load, that's a lot of money in a year's time. You know, in today's economic times, that may be a make or break number right there. You know, we got to have contingency plans. You know, as I mentioned before, if we have those contingency plans, then everybody has to know what happens and know what to do when stuff like this happens. You always have to have a plan B, because it will happen. I don't care how good an operation you have and how good your maintenance is, there's always something going to happen. Be prepared for it. This is something that's going to take place. We sure don't want something like this to happen. but it does. So how are we going to handle that? You know, if the owner is out of town or the manager's out of town, can't get a hold of him, the feeder's trying to decide what to do, we don't get cows fed for 3 or 4 hours, what does that do to our production? So it costs us on this end, but it also costs us on the cows. And here's a major problem. We got a total destroy of a mixer wagon in this picture. So now what do? You know, everybody has to understand what's plan B, how do we act on it, this has happened, and let's go. You know, we understand that things happen, but how we react to those bad things that happen is what sets us apart and allows us to be profitable. So the key with all this, details matter, but don't let them get in the way of the big picture. You know, that's a very important problem. We're sitting here, if you look, we got a bird flying at us, we're looking at the bird, but we got a big truck headed toward us. Details matter, but don't lose sight of the big picture. And for sure, don't let the abnormal become normal. When you're on a farm every single day, you become complacent with what happens. So we have to be sure that we don't let that abnormal activity or the problems that we do every day become you know, the normal for the daily activity. That's a major problem that we need to be concerned with. It's good to have somebody from the outside come in and understand what you're looking at to prevent that from happening. With that, Mark Tegler, my colleague, will take questions, and I hope you've enjoyed. I hope you get some information out of this that you can take home, or if you're going into industry, hopefully you can help your producers be more profitable. Thank you.